Hi, ladies and Mr. Sullivan. Today we're going to be looking at lesson 6-8, linear versus exponential growth. It is Thursday, April 8th. Okay, let's begin. Today's learning target is I can apply my knowledge of linearity and exponential behavior by determining if a pattern is linear or exponential. So we have learned about linear functions. We have learned about exponential functions. We learned about linear functions a few units ago, and we've been learning about exponential functions for this whole unit. So linear functions. They are based on repeatedly adding or subtracting the same amount, or the slope. The equation is y equals mx plus b. M is your slope, and b is your y-intercept. Okay. And one thing that we should know is that a linear function is a straight line. So it looks something like this, or it could be like this in direction. Okay. Exponential functions. They are based on repeatedly multiplying by the same amount, or your base. And in this case, b is your base. The equation is y equals a times b to the x, so this is a little new. A is your initial amount. Note this occurs when x is equal to 0. This is big when you're in a table of values. And then b is how much you multiply by each time. So below. The two tables below represent a linear function and an exponential function. It's up to us to figure out which is which. Explain how you arrived at your answer. Also write an equation for each. So it's very organized. We're going to say if it's linear or exponential, we're going to explain why, and then we're going to write the equation. Remember, the equation of a linear function is y equals mx plus b, which we just said. And the equation of an exponential is y equals a times b to the x. Okay. So let's look at our first table of values. What I like to do first is I always like to look at my x values and figure out how much I'm adding by each time. So let's look. So if I go from 0 to 1, I add a 1. When I go from 1 to 2, I add a 1. 2 to 3, I add a 1. 3 to 4, I add a 1. Now I go to my y values and look to see how much I'm adding by each time. Add by 5, add by 10, add by 20, add by 40. If you look at those numbers, are those numbers the same? No, they aren't. So that means this is not going to be a linear function. The reason why is because look, I go up by 5, then 10, then 20, then 40. So this is not a linear function. So now I need to figure out, is it exponential? So what we're going to do now is we're going to ask ourselves, what can I multiply by each time? Well, I know to get from 5 to 10, I multiply by 2. To get from 10 to 20, I multiply by 2. 20 to 40, I multiply by 2. And 40 times 2 is 80. So if I look, I'm multiplying by 2 each and every single time. So when I'm talking about multiplication, I am dealing with a exponential function. So this right here is an exponential function. So we're going to write in exponential function. And it's exponential because you multiply by 2 each time. Now we're going to write our equation. If we remember, the exponential equation is y equals a times b to the x. So I'm going to write in y equals a times b to the x. Remember, a is your initial amount, and it's when x is equal to 0. So if I go to my table of values, when x is 0, I get a y value of 5. So I have y equals 5 times something to the x power. Now the b we said is what we're multiplying by each time. So if we look, we're multiplying by a 2 each time. So what I'm going to do is put that 2 in here. And this is my final answer. So my equation for this is y equals 5 times 2 to the x. Okay. And that would be it for that question. Let's go on to our next example. So if I gave you an exponential, we can assume this is going to be linear, but let's show it. So the first thing we do is we go to our x values and we see how much we're going up by each time. Well, we're going up by 1 again. So 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1, and 3 to 4 is 1. Now I look at my y values. Go from 8 to 11 by adding 3. 11 to 14, add 3, 14 to 17, add 3, 17 to 20, add 3. So if I'm going up by 3 each time, I'm going up by 1 each time, I know it's linear. So I know this is a linear function because I'm adding by 3 each time. I can say because I'm adding by 3 each time, or I have a constant rate of change. Now, if we go on to this next part, when we write our equation, we know the linear equation or linear function is y equals mx plus b. So I'm going to put in y equals mx plus b. We know m is our slope and b is our y-intercept. So if I look, slope is the change in y over the change in x. So if you think about it, I'm going up by 3 and I'm going up by 1. What's 3 divided by 1? Good, it's 3. So I can say that my slope is 3, so I have y equals 3x. And my y-intercept occurs when x is 0. So if I look, when x is 0, I get an 8. So my y-intercept is 8. And that's your equation for this table. All right, let's go on to our next example. An application developer released a new app to be downloaded. The table below gives the number of downloads for the first 4 weeks after the launch of the app. So here's our table of values. Part A says, write an exponential equation that models this data. So I'm telling you, this is an exponential function. So the first thing we want to do is we want to figure out how much we're multiplying by. So if you look, when we go from 1 to 2, we go up by 1, 2 to 3, up by 1, and 3 to 4, up by 1. Now we have to sort of say to ourselves, how do I go from a 120 to a 180 by multiplication? Well, if you're not sure, just take your 180 and do 180 divided by 120. Tell me what you get. Good, I get 1.5, so I'm multiplying by 1.5. Now, if I want to make sure this is 100% correct, I just do 270 divided by 180 again. And I get another multiply by 1.5. Now I do 405 divided by 270, because I'm just going backwards, and that's another multiply by 1.5. So I'm going to write down y equals a times b to the x. I know the b is what I'm multiplying by each time, so I have y equals something times 1.5 to the x power. But here's the issue. I don't know what x equals 0 is. And that's where my initial amount occurs. So I need to find out what x happens at x equals 0. So I need to ask myself, what's the opposite of multiplying? Yeah, the opposite of multiplying is dividing. So instead of multiplying by 1.5, I'm going to divide by 1.5. I'm going to travel backwards. So I'm going to do 120 divided by 1.5, and that gives me 80. So I know my initial amount is going to be 80. So what I'm going to do is I'm going to erase this blank and put an 80 here. And this is my final answer. I get y equals 80 times 1.5 to the x power. Part B. Use this model to predict how many downloads the developer would expect in the 26th week if this trend continues. So all this is asking you is to plug in 26 for x. So we know our equation is y equals 80 times 1.5 to the x power. So what we're going to do is we're going to take that 26, and plug it in for x. So I'm now going to type this into my handy dandy calculator. And when I type it in, I get y equals 303,0140.195. But it says round to the nearest download, so I'm basically just going to get rid of this part of my decimal. This is just going to go down and disappear. So what I'm dealing with is y equals 3 million. I had to think about that for a second. 3,030,140. So I have a question. Is it possible to really download that many songs? Are there 3 million songs? No, there's not 3 million songs. So even though this answer is correct, it just goes to show you that we wouldn't really use this function beyond, like, say, week 7 or 8 or whatever, because then it's just becoming very unrealistic. All right. So ladies, that's it for today. If you have any questions, please email myself or Miss Townsend. Have a great day, ladies.